are you doing today? I'm so glad that you can join me. I was just planning out something because my parents and I are going to be working together on building a chicken coop. Pretty cool, huh? So I thought that we would draw out an outline and then make a grid to figure out how many supplies we're going to need. Like we're going to need wood and a whole bunch of other materials to make this. So I thought I'd draw out a base to see how big we wanted it. So today I wanted us to practice using our knowledge on perimeter to figure out the area of this chicken coop. You think we can do that together? Come on, let's try it out.
Right, so here is the grid for our chicken coop. Here I outlined all around the outside, on the sides, of how big we want our chicken coop to be. Do you see that? Do you remember a couple weeks ago when we were in school and we learned about something called perimeter? Do you remember what perimeter is? Could you tell me? I want you to think about that for a moment. What is perimeter?
Now since we've had a moment to think and remember about what perimeter is, let's practice it so we can refresh our memory. So remember, the perimeter is the outline or the fence of our shape. So that means that far line over there, that far line over here, this close one right here, and this other line on this side. Not any of the stuff on the inside. But remember, one way that we learned to figure out perimeter is by looking at a grid. And we can count the boxes on each side to figure out the length of each side. Let's try that. So, to help me out, I'm actually going to number these so I can figure out the length of this side. You want to do it with me? All right, ready? So we have one box, 2, 3, and 4. So if I have 4 boxes here, what is the length of this side? Right, it's going to be 4. Since we have 4 boxes long, this side is going to be 4 something. You know what? Let's do feet as our unit. Let's do 4 feet. All right. What about this one? This long side right here. Let's measure this one. Okay, ready? So we have 1, 2, 3, 4, 5, 6, and this one's going to be 7. All right, so if we have 7 boxes on this side, what is my length? I'm going to give you some time to think about that. What is my length? Right, exactly, 7. What's our units again? All right, remember, if we used feet for units on that side, we're going to have to use units of feet for the entire grid. So let's add our units. Feet. Now, what is something that we know about a rectangle? Because that is our shape right here. So this is our width. Because remember, width is when we have something that is wide. Length is when we have to reach for it, right? So if our length is 4 and our width is 7 in a rectangle, are my length and width going to be the same as what I have right here? They are. Because these 2 length sides are parallel. So they are going to be the same size. And so are these. They're parallel to the same length. So they're going to be 7 on this side, just like 7 feet on this side, and 4 feet on this side, just like this side's going to be 4 feet as well. So let's label those. So we have 4 feet
And then I'm just gonna write 7 down here. So we have 7. I don't know if I can write upside down. Feet. There we go. All right. So now to find perimeter, what was our main thing that we did? Exactly, we added up all the sides. So we have 4 plus 7 plus 4 plus 7. I'm gonna give you some time to think. What's 4 plus 7 plus 4 plus 7? So I have my equation drawn out right here to show our length and our width and our other length and our other width. So we have our perimeter equals 4 plus 7 plus 4 plus 7. Since I've given you some time to figure that out, let's do it together just to review. So let's do this part first. If we have 7 plus 4, we have 7, 8, 9, 10, 11. We have 11. And since we have the same here, I'd know that this is going to be 11 as well, right? So what's 11 plus 11? 22. Exactly. But 22 what? Feet. Don't forget those units. It will be 22 feet. So now since we've had a moment to review and think about what perimeter is, since it's been a while, now we're going to use that information that we learned to help us with learning a new topic. Are you ready? So today we're going to be using our knowledge about perimeter to learn about something called area, also known as the space inside a shape. So the perimeter taught us about how to measure the length around a shape, right? So like that fence. But now we're going to be looking at that area within a shape. Okay, you ready? It's pretty exciting. So let's see. There are 2 ways that we can do this. One way is we can use our knowledge of perimeter from what we counted for our sides, our length, remember our length, and then our width. So we had 7 as our length, as our width, and then we had 4 as our length. So we can either multiply those 2, we can do 7 times 4, and that'll tell us all these squares. How many squares are inside this entire shape? Pretty cool, right? Or we can also count each of the boxes, and that'll tell us the exact same thing. So what I think we should do first, just to get some practice in, is we should count these boxes together. And one way to keep track of your counting, because sometimes we lose track while we're counting, right, is to label each box. And I'm going to do that with chalk today since I'm on concrete. And yeah, that's how I'm going to keep track of my counting. So let's try this out. So I'm going to start labeling, and I would like you to follow along with me. Let's count together. All right, ready? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm gonna let you guys count a little bit. Good. Okay, I'll join again. 20, 21, 22, 23. I'm gonna chalk a little bit. 24, 25, 26, 27, 28. All right, so now we've labeled all of our boxes. This is how we can find the area. Since we have counted each individual box and labeled them with a number, now we can just look at that final box with our highest number, and that is our area. But remember, we're measuring for square units. So let's check our answer really quick. Since we said that our area was 28, I wanted to make sure my answer was correct. And I'm going to do that by checking my answer through using the other strategy. So our other strategy was using our formula, area equals our length times our width. So that is 4 as our length and 7 as our width. So let's solve that. 4 times 7. So since we've been learning a lot about our math facts and we've had a lot of practice with our times tables, I'm going to give you guys a second to think about this one. What's 4 times 7? All right, cool. Well, just in case, I'm going to go over it too. So, if I'm confused about a multiplication problem, I like to break it down just a little bit further. Okay. So, I can also break this down to 2 times 7 and 2 times 7, and then add those two together. And that'll be the same thing as 4 times 7. 2 times 7 is 14. And then 2 times 7 is 14. And so 14 plus 14 is 28. And so if I have 7, I can also do it this way. 7 plus 7 plus 7 plus 7. We have 7 plus 7 is 14. Plus 7 plus 7 is 14. Add those two together and we have 28. So our area for our chicken coop is going to be 28 square and then it'll be units. And the units for this grid is feet. So our area of the square is 28 square feet. Pretty cool, right? All right, so thank you for joining me outside and helping me figure out the area of my chicken coop. And hopefully in a couple weeks, you'll get to see some of the chicks that we get. Pretty exciting. So now let's go back inside and talk about area a little bit more using an anchor chart. And then let's get some practice going with our practice book, all right? Let's go. All right, so welcome back indoors. Let's review our knowledge about perimeter once again, and then let's bring it back to area. All right, so remember the perimeter is the distance around the outside of the shape. So remember when we compared it to a fence. So it's like that, out, very, very outside. It's that fence all the way around the shape, all the way around the yard. All right, and so I have a couple examples here. So we have a rectangle, triangle, and what kind of triangle is this again? Yeah, exactly, that's our isosceles triangle. And then we have another shape right here. What is this shape called? Let's use our knowledge about polygons. We have 1, 2, 3, 4, 5, 6 sides. So what is this shape called? Yep, it's a hexagon. Nice job. All right. So then our perimeter, remember we add up all the sides. So this rectangle has a width of 12, and a length of 6. So we have 12 plus 6 plus 12 plus 6. And for here we got 36 inches as our perimeter, because 12 plus 12 is 24, and then 24 plus 6 is, 30. And then 30 plus 6 is 36. Nice job. All right, and then for our isosceles triangle, we have a side of 9 inches, 9 inches, and 9 inches. And so then we added all of those sides up and we got 27 inches. Let's look at this one. So for this triangle, we had this side was 14 inches, 7 inches, 12 inches. And so we added all of those sides up and it got 33. And then for this one, we have quite a few different sides. Remember, in perimeter, we have to look at every single side, not to miss anything, because we have to know the entire fence line of that shape. And so we added 3, 15, 10, 7, 8, and 7. And when we added all of those up, we got 50, right? Yeah, exactly. So perimeter is that distance around the entire shape. Remember when we did that outside? We looked at the entire outside of that chicken coop. And then we have area. And area is the measure of space inside a shape in square units. Remember, we did area outside in 2 different ways. We used this formula as one of our options that we actually checked our work in, and that was multiplying our length and our width. And then we have another way where we use our grid, or the squares inside, and we count them to find the area as well. So both of these work. It's up to you which one you want to use. If you want to use both, that's also really great practice. So we're going to do this anchor chart together so we can learn more about area. Are you ready? So first I'm going to look at this rectangle and I'm going to start counting each of the boxes. And then, like outside, I'm going to go check my work by looking at this formula. Okay? So let's count these together, and I'm going to label them as we count. Ready? So I'm going to step on this side. So while I start numbering, I want you guys to count along. So that way you guys are following along with the counting as well. All right, ready? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, make sure you're counting along, 34, 35, 36, 37, 38, 39, 40. Whew, almost there. 41, 42, 43, 44, 45. Wow, oh my goodness. Whew, that was a lot of squares. So how many squares did we have in all? Yeah, we had 45. So then we would say that our answer would be 45 square units, right? So 45 square units. I'm gonna write that on a post-it note because we're still gonna check our answer. All right, and then to check our answer, we're gonna do our length times our width. Do you remember how to do that? Yeah, exactly. It's just like how we were doing our perimeter. But here we have boxes. So now we need to count the boxes on the outside on this one side, on this one side to find out our length and our width. So for our length, remember our length is going to be this side. So we have 1, 2, 2, 3, 4, 5. So our length is 5. And let's check our width. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so we have a length or a width of 9. All right, so then we would just plug it into this formula. So let's check it. So we have area equals, and then our length is 5 times our width is 9. So what is 9 times 5? What is 5 times 9? I'm going to give you guys a second to figure that one out, and then we'll go over it together. All right, ready? Okay. So I like to kind of skip count, and I know best are 5s. I'm not so great at skip counting with 9s, so I'm going to try 5s, and I'm going to count to 9. So we have 5, 10, 15, 20, 25, 30, 35, 40, 45. All right, so 45 square units. All right, so that would be our answer then. Does it match what we have for our counted number of boxes? Yeah, it sure does. So like I said, either of these different strategies will work. There might be another one too. And if you do know another one and you want to share it with us, please tell me. You can tell me on our Zoom conference in a couple days, or you can also message me in the comments or on Zoom too. So that would be awesome if you could find out another way. But these two are pretty cool. They work really well. All right, so now let's look at this one. This one's really big. I think it's going to be more than 45. I think we should count this one too. I'm going to use green this time to count. All right, remember, just follow along as I write down so you can keep track of how many numbers we have. Ready? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, wow, 50. All right, so this entire shape had the area of 50. That's crazy. So since we have found that our area is 50, and then we need to check our answer by looking at this formula, the length times width, I've noticed that this shape doesn't have an exact length and width. it has many different sides and many different lengths, many different widths. So this formula won't necessarily work for a problem like this. So that's where one formula or strategy or another will work best. And that's for you to decide. So now we had just found area for two regular shapes. We had our, what was this? Yep, our hexagon. And then we also had our rectangle. So since we found the area of those, we had 45 and 50. We also need to know something that's really important. In our practice, we might come across other problems in other shapes that are known as irregular. And in order to find the area of those, we need to first isolate the squares that are complete. Okay? And then we need to find the area of each. And by that, we mean like our counting method, right? And then we would need to look at those other shapes that might be like part of a circle, part of a triangle, that might not be that perfect square or rectangle in some cases, and figure out and estimate basically how many squares it would take to fill that space. All right, so for example, if we turn to page 14-1 for covering regions in our workbook, and then we come to a problem like number 1. And in number 1, we're looking at a circle. And in this circle, we can see that there are some squares that are complete. However, we also have some squares that are not complete, like this one. Basically all the corner ones, they kind of look like they're cut in half almost, right? So to find the area of something like this, we are going to first look at the boxes that are complete. So see how this box is it's just complete. And then this box is basically complete, and so is this one, and that one, and that one. So we are going to count all of these boxes as one. And then we are going to look at these corner boxes that are not complete and look more like a half, kind of like number 3 over here. And we're going to count 2 boxes as one box because they are both a half. And this allows us to find the estimate of this irregular shape. So now on my whiteboard, I rewrote the problem just like it is shown. And so I have 1 full box, 2, 3, 4, and 5. So I have 5 complete boxes. But now I just need to add a couple more to find the estimate. So we said that this one was a half, and this one was a half. We know that 2 halves is a whole, so I'm going to add a 1. And then we had another half over here, then another half over here, and we know that 2 halves is a whole. And so my total boxes, or my estimate of the area of this circular shape, I would say is 5, 6, 7, would be 7 square units. This is an estimate to find out the area of this irregular shape. Since we've worked outside to help us remember about perimeter and then learn something new, area, now we're going to use that information that we've learned and practice some problems. So now if you can get out your workbook, or if you don't have it, let's log on to that envisionmath.com. We're on unit 14 in the first section. So I'm going to be on 14-1. If you guys can find that practice page, I'm going to go over a couple problems so that way you guys will be ready to go and practice on your very own. So let's work on problems 1 and 4 together, and then you guys can work on the rest and the reteach. The reteach just has a couple problems, and that reteach number 1 we actually were able to do together just a minute ago. This is a diagram of the picture drawn on 14-1, the practice page. This part in the orange is our soccer field. The green is the baseball field. The purple is the tennis courts. And then the pink is just an empty field for the school. So for problem 1, the question reads, what is the area of the soccer section of the field? Okay, so to do that, we have 2 different strategies we can use. We can use our formula with a length and width, or we can use our counting strategies. So for this one, I'm going to just use 2 of the strategies. I'm going to use the counting first, and then I'm going to check my answer by looking at that length and width formula. So for this problem, I'm going to model how to solve, and then for number 4, we're going to work together to solve that other problem. All right, thinking cap on. So to solve this problem, I need to know the area of this shape, what's in orange. So something that I wanted to do was count, because I feel like that is really accurate. And so to keep track, I am going to write each number inside the box. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, so from the counting method, I got 18 square units as my area for the soccer field. I'm going to write that down right here. 18 square units. But to check my answer, I'm going to plug it into the formula. A equals length or area. A equals length or L times W or width. So my length, let's see. My length, I'm reaching out. So my length is 1, 2, 3. I have a length of 3. And my width is 1, 2, 3, 4, 5, 6. 6. So to find area, I need to multiply length and width of 3 times 6. Since I've been working on my multiplication problems, I know that 3 times 6 is 18. And therefore, my answer of 18 square units for the area of the soccer field is correct. All right. So now since we've worked on practice problem 1, or I've modeled it, I am going to have us work on question number 4 together. And question number 4 says, if the school used the soccer and baseball fields, so the soccer field that we just used, and then the baseball field, which is green, to build a football stadium, how large could the area of this stadium be? Okay. Well, we already found the area of the soccer field. So, how do you think we can figure out the area of the soccer field and the baseball field? I'm going to let you brainstorm for a minute. There's a couple ways that you could do it. All right. Well, since we can't really communicate with each other, I'm going to show you a way that I would think to do it. So, since we already found the area for the soccer field, and we ended at number 18, I can use my strategy of counting on to find the area of this baseball field in addition to the soccer field. So I can just keep counting from 18 to fill in the rest of these boxes. Pretty cool, right? All right, so let's count together then. Ready? 18, 19, 20, 21, 22, 23, 24, 25, 26. Awesome. Very cool. So now we know that the soccer field and the baseball field have a total of 26 square units. Let's write that out. 26 square units. All right, so that's one way that you can do it. Or you could count all of the square units inside the soccer field and then individually count the number of square units within the baseball field and then add those two up. Or is there another way? Can you tell me? You can also write me in the comment section and let me know. Now we are done with our lesson. I would just like us to think about, what did we learn specifically about area? What did you learn? How can we use that outside of our classroom? How can you use it out inside the world, at home, and beyond? Tell me in the comment section because I would love to hear it. Based on this lesson, we learned that you can use area to find the space within a chicken coop. Kind of cool. All right, and then before we get going today, I do have a little bit of trivia. And my question today is, what number is exactly halfway between 1 and 7 on the number line? All right, so now you get to use something that we learned quite a while ago about number lines to find the number that falls between 1 and 7 on a number line. Stay tuned next time to find out the answer. Until next time, thank you guys for joining me. Stay happy, stay healthy, stay safe, and I will see you very soon. Bye.